Hello, everyone, and welcome to Cisco Unplugged. I'm Dan Klamert, your host. And this week on episode 58, actually, this is now our 100th video on the channel here. So, something to kind of be proud of and celebrate. But we have a very exciting and special update from the Cisco Wireless CTO Office. So, first off, I would like to welcome back to the show Al Dumdei. How are you doing, Al?
Hey, good, thanks.
I see
And
you're all
just
dressed up this morning. Hopefully you're not interviewing or
no,
something.
I I actually have to go out of the office and visit people today.
Oh, that's good. That's good. I like
Yeah.
that.
So, but by way of introduction, I know since we talked about Dan and I, but been really looking for like somebody good looking we could put on the show, right? That's been a real important thing. So we've been looking for somebody. But in lieu of that, we got Malcolm. We got someone with some information.
Thanks, Al.
Yeah, so thanks, Al. Malcolm, he said it. I didn't say it, but so thank you very much, Malcom Smith. I'd like to welcome you for the first time to the show today. And Malcolm is a principal engineer in the Cisco Wireless CTO office. How are you doing today?
Good, thanks. I'm glad to be here. And thanks, Al, for for inviting me to the session today.
Yeah, Malcolm and I are fellow
Watch out,
bikers.
Al. Payback is, is, you know what. All right. So before we get into it here, I just want to have a few reminders. If you are watching live right now, we do take questions via Slido as normal. So you can scan the QR code on the screen to get joined to the Slido so you can ask some questions. The link is also available via the YouTube video there below it. You'll see the link to the Slido and you can join there. So feel free to jump in, ask any questions. We can hopefully get to those here live on the show if you've got some. And then as usual, we are recording this and it will be available on our YouTube channel, which is youtube.com/@getunplugged. So please go out and like and subscribe and click the bell to turn on the notifications so you are notified when we do go live with other great content like this. So I think that's it for the reminders. So now let's get unplugged. Malcolm, let's talk a little bit about some of the cool stuff you're working on here in the Cisco Wireless CTO office.
Absolutely. And so I think I'm sharing my presentation, and I will continue from here.
Yep.
So yeah, so this title really is Wi-Fi evolution. I'll talk about how Wi-Fi is evolving to meet the use cases in the enterprise and sort of our space, and how we're adapting that to the application. So the first one, obviously, is what we call mission critical wireless. These use cases have been around for quite a long time. But in particular, we've had use cases around warehousing, robotics, safety control systems on the bottom right. Again, looking at the use cases where there is a very high need for mission critical service delivered by the Wi-Fi network, both high bandwidth and also low latency or better latency. That's always been a challenge for Wi-Fi. Even the financial systems you see using real-time trading, they want low latency between the different network segments. But particularly in healthcare, shown here, a sort of AR/VR use case using that to operate on a live person. So obviously, timeliness is very critical for the successful procedure for the patient. Talking about AR/VR, AR/VR is definitely becoming very popular in enterprise and other consumer spaces, be it collaboration as an enterprise service, shown here, bottom left, or education purposes in the schoolrooms and classrooms. These are very popular now, and you just see the bottom right, obviously the revenue share for B2B, business, and also B2C for consumers is also ramping up quite well. And so the key here is that we need to have, and Wi-Fi networks have both the high bandwidth, which Wi-Fi is very good at. No one generally complains about Wi-Fi being too slow, but they always complain about Wi-Fi not having the right kind of reliability or predictability, or what we call determinism, if you want to use that word, but really bounding the latency at high scale, number of users going from 10, 20, 30, 40, 50 per access point in a classroom or what have you, it becomes challenging to maintain those bounds while you're adding density. And so to summarize our sort of path to reliable Wi-Fi, Wi-Fi 6E really was the first version of Wi-Fi where we sort of could control the interference in the environment, controlling the stations, the endpoints that produce most of the interference. Traditionally in Wi-Fi 5, that could be somewhat controlled with Wi-Fi 6 and 6E, providing more spectrum to mitigate co-channel interference. But Wi-Fi 7 really is the first attempt by Wi-Fi to explicitly control the experience from the user point of view, to provide a SLA or bound around the latency. That comes in the form of MLO, multiple operation. I'll talk about that briefly, but also some explicit mechanisms called SES and RTWIT, which we'll talk about more. Don't focus on the terminology right now. We'll get to it in a minute. But that's just the first version of Wi-Fi where we have explicit protocols to actually achieve a certain outcome in terms of delay from the point of view of the user's application. Then Wi-Fi obviously takes a bit further with the multi-beat coordination or MAP-C, and also seamless roaming. And that's sort of set the stage for evolution of Wi-Fi. Not quite there yet, but certainly going in the direction of controlling the experience to make it more reliable for the end user.
Hey, Malcolm, before we jump to the next slide, we already have a question here.
Sure.
And it was around the AR slide and discussion there. So the question is around what kind of requirements, and maybe Al, this is for you or Malcolm, but what kind of requirements are there for a wireless network with AR? And is this a 6 gigahertz only thing? That's the question.
I can probably take it. I mean, so AR is a bit less onerous than VR or MR, but AR tends to be low bandwidth, megabits per second, but it still requires the tight, very tight, low latency control, because you want to be able to, for example, move your head and instantaneously the head-up display shows, what is that object you're looking at. That requires very tight still latency between the glasses and the phone, or glasses and the device and the access point. That's still a requirement for AR as well.
Sure.
Yeah.
So certainly not a 6 gigahertz only thing.
Yeah, I mean, 6 is better. I get to why it's better in a slide.
Yeah, it's
but
better for sure.
better.
Agreed.
Yeah.
Yeah, and I think what Malcolm is showing here is there's kind of an inflection point in the industry, right? It used to be all about speeds. That was the question we used to ask, exactly what you just asked. Do I have enough bandwidth to do this application?
Yep.
Well, now we've got wider channels, we've got more spectrum. The speeds and feeds generally are not the question now, right? So now it's more about how do we keep that consistent latency, low latency, that minimize the jitter and that sort of stuff. And as Malcolm's pointing out, we're seeing a whole inflection starting with the standards committees, right? The focus is changing now from speeds and feeds to reliable communication.
Yeah. All right. Thanks.
Thanks.
Appreciate it.
And so what we're doing here really is showing that to maintain that bounded latency or variability, we are actually putting things in the protocol with Wi-Fi 7 and Wi-Fi 8 to actually achieve that for the broader ecosystem of devices out there. So as Al mentioned, Wi-Fi 6E does have more spectrum, and certainly can achieve that through deployment of certain reuse factor or channelization bandwidth to achieve that reliability. And in some cases, you can get, for example, with 1.2 gigahertz and 6E, very reliable connectivity in wide channels. But other markets, Europe, for example, that's not possible to achieve that wide channel as well as having reliable. And so you need to have technology on top of that to ensure that in the case where you can't just throw bandwidth at it, and by the way, bandwidth doesn't always solve the problem. It's something that doesn't make it go away in terms of QoS and jitter, et cetera. So you have to have a solution around technology, protocol, collaboration between the stations and the access points to achieve that low latency that you want throughout the entire system. And that's what Wi-Fi 7 is providing. I'll go into the deep dive of these technologies, but I will say that the problem is sort of multifaceted. The first problem you sort of see in Wi-Fi is essentially putting traffic in the right class of service. That's been around for decades, obviously, in Wi-Fi, but there's technology like L4S that helps to assist the network in putting traffic in the right class. Wi-Fi 7 will have what we call streaming classification service, or SCS. SCS is a way for the endpoint to indicate to the network which particular flows are important to you. So if you're doing an AR/VR session from the cloud, what this allows you to do is say, hey, my AR/VR session is very high priority. Please put that in the right class of service for me. And the second thing that this does with Wi-Fi 7 SCS is exchange what they call the cross characteristics, or QC for short. And that will tell the AP exactly when the traffic is being transmitted by the station and ensure that the jitter effectively is removed from the equation. Because if I know when the traffic is coming from the device, and I know it's very high priority, I can schedule that transmission very accurately towards the station and achieve a very low latency and very low jitter outcome for the application. MLO does help as well, but not as much as people think. I'll share that in a slide or two. The other technology in Wi-Fi 7 is what we call Wi-Fi 7 RTWIT for short, called Restricted Target Wait Time. In short, what that does is establish time slots where no other station on the air can transmit. And if that's the case, then we avoid having interference mess up my very nice and delay and jitter performance that I had with Wi-Fi 7 SCS, because you can do all you want to schedule the station on the channel, but if other stations take that transfer opportunity or takes off, then that nice jitter goes away and gets degraded. That's the goal of Wi-Fi 7 R2. So that's basically the Wi-Fi 7 capability. I'll share with you some expected results from those technologies. First of all, I'll take the case of Wi-Fi 7 in Europe. Let's say 5 megahertz of spectrum to play with, maybe less. Typical channel size, there's going to be at best 40 megahertz. Again, back to our reuse factor discussion, reliability has to be met as well. And so we see with the technology we have on the table, all of a sudden no QoS, that really sucks. Very high latency, a quarter second, not good. Our basic WMM or L4S QoS does quite well to manage latency, but we're targeting 10 milliseconds of latency here for XR and industrial control systems. So 50, 40 isn't good enough. The only way we really get to that 10 millisecond or 1 millisecond boundary is using the SCS QoS characteristics and the RTWIT technology from Wi-Fi 7, R1 and 2 to achieve that. So that's something to think about in terms of what technology trains to ride. 7 definitely performs much better than 6, and definitely without QoS, you're sort of shooting in the wind. So that's Wi-Fi 7 in Europe. And US, you have more spectrum to play with. You can actually do a better job. And what that shows here, and to the point that Al made before, just with adding more spectrum, more channel bandwidth, that's actually reduced the latency quite a bit as well. So shown here, if we go from a standard 40 meg channel, which is very common today, to 80 megahertz and 6E, then we do essentially half the latency from 25 to 10. And so even with 80 megahertz, we're very close to meeting our 10 millisecond target for XR and industrial applications. And we do achieve that reliability and in terms of that at the same time. And 160 makes it even better. But I'd say that 80 megahertz is a sweet spot here because that's a very common channel bandwidth we can deploy in the US and FC regions. But so we can achieve that low latency with that channel bandwidth. So I think it's very good for IoT, very good for XR or AR deployments. In the US, we definitely achieve that outcome with very high reliability, but also bounded delay, showing her down to 10 millisecond area. Okay.
And Malcolm, real quick, because I've seen this in a number of slides, maybe just so everybody is aware, what is SCS in this context?
So yeah. So it is SCS. So the term in Wi-Fi 7 SCS is Stream Classification Service. That's a flow-based QoS, and the QC means cross characteristics. So what you do is you exchange with the access point the exact requirements for your flow. So if you're requiring, 100 megs per second in the upward direction, and you require service every 10 milliseconds, you'll tell the access point, please give me channel access every 10 milliseconds for my 1,000-byte packet. And that guarantees effectively that your station is not blocked by any other station with low priority traffic on the air. That's a big difference from Wi-Fi 6 and before.
Yeah, interesting. And so that's, again, in that focus of keeping a consistent stream, more reliable communication link, this is now working on flows as opposed to packets, right?
Correct, yes.
And then TUA-O?
So that's also see that in the terminology. That's triggered uplink access, that's optimization. That's the actual tool the access point uses to trigger the station at that prescribed time. It says at time, every 12 milliseconds, I will trigger that station with that high priority flow to send in the uplink direction by a very important XR or AR packet to the access point.
Perfect. Thank you. Very helpful.
Thank you for the question. And so given all that, there's a technology that's being promoted for about, I'd say 10 years now, called TSN, or time sensitive networking. And that's been available in the wired network for a long time. But now with Wi-Fi 7, we actually can extend that TSN to the wireless domain and the Wi-Fi in particular. And so using two generally available techniques. One, on the left is to synchronize the applications with the network. The key here is that if the access point knows when the traffic is generated by the station, then it can schedule accordingly. So TSN, shown here, is a way of synchronizing all the endpoints, all the application, the endpoints to one single clock. GPTP in this case is used for that clock. And then over the air, synchronize the station with the access point's clock very accurately, right? So in this case, we're talking about 1 nanosecond accuracy in theory, and measurement synchronizing the station to about 1 microsecond of the access point's clock. If that's the case, you can schedule and trigger the stations at the precise moment to achieve a very, very low latency outcome and a very low or no jitter outcome as well. And FDM is now becoming more broadly available. We see on access points, new access points. We see it in Samsung devices, etc. So FDM, the key enabler of WTSN, is now becoming very popular in ecosystem in general. The second component of that is actually the scheduling component, because in wireless TSN, the notion is we define time slots or gates. Gates open for your traffic to be transmitted, and they close when no one else is allowed to use that time slot. So this is very key to achieving, again, the low latency and the very low jitter or zero jitter in this case. And so with Wi-Fi 7, with our cross characteristics and target access mechanism and RTWIT to reserve over the air those time slots, we can align those over the air time slots with the TSN QBV time slot. So now everyone has a guaranteed time slot for channel access across the entire network. That's very key, because now the application generate their traffic at the prescribed time based on the synchronized clock, and that channel is open for them to flow right through the access point, right over the wireless link to the endpoint at the precise time, giving you a zero jitter outcome. That's very reliable, very predictable, and very much in line with wired TSN performance. So that's a very key sort of evolution of Wi-Fi towards this very highly reliable wireless TSN outcome. And here's a graphic. Okay. And so the other use case beyond the industrial IoT and the warehousing, which you see WTSN be deployed in, is the AR, VR, XR ecosystem. And so this is something we've been working on for multiple years within the Wi-Fi Alliance. I'm at the vice chair of the market segment task group within the Wi-Fi Alliance for XR, looking at all the use cases around enterprise AR, enterprise VR, enterprise MR, and working with obviously our key partners like Meta, Qualcomm, and Broadcom to achieve this. And the use cases we see in enterprise are quite different than consumer VR or consumer AR. Because in consumer AR and VR, it's what we call a standalone solution, as in you put a headset on your head, it contains all the compute, all the rendering, all the control functions on that one device. But that doesn't scale very well because you're really constrained to now using a lower power GPU, lower power CPU on that device. And so what you really want to do is offload the XR video rendering to the edge cloud, and it's shown here. And when you do that, now you have access to infinite compute on the edge. And there's for example, Cisco collaborated on this a couple years ago to optimize that for enterprise networking. But effectively, you offload the compute to the edge. But now it means that the link between the access point and the XR device is now time critical because there's now zero time or very much zero time to deliver that frame over the air to the device. And then as you move your head tracking must be reported in real time to the access point such that the edge cloud can now compute a new frame for you, a new video frame for you. That loop has to be, as I said before, 10 milliseconds. And so this is now very critical to achieve low latency over Wi-Fi to support this edge cloud rendering style of XR, which we do see as being the predominant XR deployment mode for enterprise, where the compute is offloaded to the edge cloud. So we're working with various partners on this. We're using Wi-Fi 7. The techniques were described in this presentation to achieve this low latency outcome. And I think we'll see a Wi-Fi Alliance certification or XR in particular next year to drive this from the market and allow multiple devices, not just Meta, other devices to adopt this technology within the Cisco ecosystem as shown here. So as far as more information, I will shamelessly plug our textbook. We just published this textbook months ago. Myself, otherwise from Cisco, Jerome, Henri, Brian Hart, Gupta, also very good engineers in Cisco, part of our Wi-Fi standards team as well. So we've been driving Wi-Fi 7 standards for about 2 years now. And the outcome, obviously, part of it was the QoS and the determinism features we talked about here, also MLO. But if you want to find more about Wi-Fi 7, feel free to scan the QR code and get a textbook on this topic. The other contribution we're making in Wi-Fi 7 are shown in IEEE, for example, the benefits of QoS, the benefits of Wi-Fi 7, triggered access, and SES, MLO. They're all shown publicly in the references here. So if you want copies of those slides, those presentations, they're available to you on IEEE, on the Mentor for free. Last but not least, Wireless TSN. WTSN is a technology we're pushing through Avenue, which is a group that sort of certifies IoT devices for low latency and determinism and Wi-Fi. That's also a reference for you as well. And so with that, I think I will take questions or take any comments.
Awesome. So just another kind of quick plug for the book. The book has both, there's a soft version and there's a hard version. So you can get, and I actually have both because I like to be able to look things up quickly sometimes in the soft version, but if I want to sit down and read a chapter, I like to have a hard copy. So, and I see this book recognized in a lot of circles that are, very, like standards-based and stuff like that. So well done on the book. It's a very thorough book. Maybe just a little bit more about so you were talking about AR, VR in the Wi-Fi Alliance. Maybe let's because I know the CTO office does a lot of work in standards and both in a number of different areas. One of them is the Wi-Fi Alliance. In the Wi-Fi Alliance, the Wi-Fi Alliance generates specifications and test documents that the industry then tests to. Can you talk a little bit about how that process works? How do these documents get approved? How do they get generated? I mean, how does that kind of process to drive? So with 802.11, we have lots of options and things like that, right? But when you get to the Wi-Fi Alliance, it's sort of mean, and correct me if I'm wrong, but it sort of limits those options and said, here's the combinations we want to use. Who determines that? How does that work? How does that get approved? That kind of stuff. So maybe tell
That's
us
a good question. So it starts with IEEE. IEEE 802.11 will basically provide technology base, or I call it toolbox, if you will, of technologies you can choose from, right? But what WBN, what they do with WBN does not prescribe the market feature set. So Wi-Fi Alliance determines from the set of IEEE technologies, 802.11 in general, BE for Wi-Fi 7, BN for Wi-Fi 8, for example, they will down select those features that make the most sense for that market. So for the access certification showing here, for example, we'll pick and choose the technology Wi-Fi 6 and 7, for example, the SS, the triggering, the cost management, those will be down selected from that base 11BE spec. And then we'll definitely pick the features that add the most benefit to the use case. So based on that value to the use case, the certification will include those features to be tested by the Wi-Fi Alliance and their partner companies. That's how we sort of select the technology, because the 11BE, the directly specs are very, very large. I think it's like 7,000 pages now in Wi-Fi base 11 text. And so for that 5,000 or 6,000 pages, we down select the 100 or so pages that make the most difference. And then we test the key features from those specs that provide the most value to Cisco customers. And that's why the certification around Wi-Fi 7 or 8 or XR in this case is actually more valuable than the actual IEEE spec itself, because it does contain the key features that add enterprise particular value.
My understanding is also just something that's a little bit different between, say, like 802.11 and Wi-Fi Alliances. 802.11, you can send 100 people to, and they each get one vote. With the Wi-Fi Alliance, when we do these standards, it's one company, one vote. Is that correct?
It is, and you might think, well, there was Cisco a massive advantage. Well, it's true. I mean, in .11, you tend to have different packs, different groups that have various interests, and you're right. You have 200, 300 different voters in .11 BE or .11 BN. But when it comes to the market adoption, it goes down to a much smaller set of companies. Mostly companies that are focused on enterprise market, the SP market, et cetera. And those companies, as you said, have one vote per company as opposed to per members. Now, does that mean Cisco has an unfair or some massive advantage? Not so much, but we definitely have a stronger voice in terms of biasing the feature selection towards enterprise features based on our customer requirements.
Right. And then the other is that, and I know your boss, Matt McPherson, is, I think he's on the board, right, of the WBA, right? So the Wi-Fi Broadband Alliance, that's another thing the CTO office participates in, right?
Yeah, so the Wireless Broadband Alliance, WBA, is a very big venue for Cisco, because it brings together both enterprise customers, enterprise vendors, but also SP and M&O vendors as well, into one forum. And for example, there's problems in WBA that go outside Wi-Fi Alliance, which is focused on, let's say, device to AP communication. WBA scope is much wider than that. It includes the whole network. So for example, open roaming came from WBA, and that's an end-to-end solution between service providers, M&Os, enterprises, and also all the vendors in that ecosystem. So that's a good example where going beyond the Wi-Fi link, the Wi-Fi network, is very beneficial to Cisco to provide end-to-end solutions like open roaming, and in that context.
Super. Thank you. Dan, is there anything else question-wise that came in from?
No, we had one other, I took care of it, addressed it. There was something we had covered more in depth in a previous episode 17 on FTM, but no, that's it. I don't think we have any other questions.
So. Malcolm, thanks for doing this. It's always a pleasure to have you present. I always learn something every time we talk. So
This
It's
is
great to
great.
see.
Yeah. Thanks a lot, Malcolm.
Thank you.
Great update from the Wireless CTO office. So I don't see any other questions. So with that, I will remind everyone to you can check our upcoming schedule list now. We have a published schedule of our upcoming next few episodes out. If you go to youtube.com/@getunplugged, the first link you'll see below the kind of the title graphic is a link to our schedule, so you can see what's coming down the road here. And we do have in a few episodes, couple episodes now, we have our live from Cisco Live episode. So if you see us out there, say hi. We'd love to chat and connect out at Cisco Live in San Diego. So if you want to reach out and connect with us, you can always do so via your Cisco account team. You can email us directly at getunplugged@cisco.com. You can DM us Twitter or X at unplugged80211 or on Threads Unplugged Connectivity. So with that, I would again encourage you to go out and subscribe and turn on notifications to the channel so you will be notified when we do go live with other great content or post other great content. Thanks again, Malcolm. This was great on our 100th video here on the channel. So appreciate you sharing your time and insights with us. This was great.
Thanks. It's been a pleasure. Thanks for the offer. And
yeah, anytime. Thanks a lot. And until next time, stay connected and unplugged.